Now, see the piping layout. Tank form piping. Voice. Okay. Here, to determine the optimum location of pumps and potential hazards and the client preference shall be considered with the help of location of pump within dike area with the curb wall height of approximate 400 to 500 millimeters. So here we have to install the pumps, different kind of pumps we have to install and to study the design that protects the pump from minor spillage within the dike and enable the discharge piping to exceed the dike over the wall. So here you have to consider the curb area and there is no need to have dike penetration in the particular piping industries. So therefore, dike may run in a pipe rack or sleepers. So in next sketch, you will see here the location of pump within dike area with curb wall height approximate 400 to 500 millimeters and the pumps located outside the dike and can be illustrated with the help of this sketch. And tank outlet. Tank outlet piping can either penetrate the dike or pass over the dike in case the minimum liquid level in the tank to cause cavitation. That is the problem. But I said. Now check it. Okay, fine. Okay. Pumps located outside the dike area, so illustrated in this sketch. So here you can see the tank outlets and the temperature routines there. Here we can consider the ground elevation so that outlet piping either penetrate the dike or pass over the dike. The dike in case the minimum liquid level in the tank to cause cavitation in the pumps. So therefore, to consider the adequate maintenance area around the pump shall be prime consideration for planning the piping arrangement at section as well as discharge ends. The piping arrangements, the optimum piping arrangements in tank forms. So here we can consider the optimum piping arrangement in tank forms. The most cases, the direct routine between 2 points. Like here, first one is a tank nozzles, another is a prime layout consideration of the pumps. And the layouts here we can consider for their normal line expansion and stresses. So you can see the illustration between the tanks and the pumps. With the help of this layout, we can accommodate the line expansion between the tank and nozzle. Is it visible online? And manifold headers.
Yes, sir.
Okay. Expansion loops may be added at the sleeper level. So here in future expansion, what we are considered, the future expansion with the help of rack width calculation, actual rack width calculation and future calculation with the help of two numerical relations. So we found, and we have to lay down the expansion loop in the sleeper levels in the process industry or petrochemical industries. Then we can install the different kind of pumps. Let us see the different kind of pumps what we are learn in fluid mechanics. Is it correct? We have learned different kind of fluid pumps, reciprocating and rotary pumps. Again, they are classified into different kind of based on their motions and axial direction. So that kind of pumps, so we can install in processing industry or petrochemical industries. Now here, this is a typical layout. Here we can consider in LNG tanks. So that kind of liquefied natural gas are installed in ONGC plants. And that kind of tank arrangements are essential when we have to consider in particular layouts. This depends upon the entering their respective areas where we can install the different kind of liquefied natural gas. And already we are discussed about the location of walls. In location of walls, we have to consider their minimum and maximum height whenever we are considered the operator levels. This is very essential. If distance between the location wall and operator size, then we can go for that kind of structures. Then we can consider their particular locations in these areas. That kind of yard piping can also run on the wall locations. In wall locations, we have to consider the orifice flanges near rack columns for access. With portable ladders, orifice runs or after pump can be located near supporting columns. At the plants and various structure elevations are determined by the guidelines of the requirement of header room given above the size of the surrounding beams and also taken into account while finalizing the structure levels. Generally, the process lines that contain two lines located at level higher than the top tires. So here we'll see the top levels, and we have to consider different kind of tires, that is a first tire or second tires. Based on that lines having one end located at elevation lower than bottom tires and can run the top or the bottom of the tire. See, both ends of a line are lower than the bottom tire, the line should run on the bottom tire of the rack. The elevation of the lines can be influenced by the walls and instruments location. Access platforms are required to be provided if walls are to be placed on the top of rack levels. The consideration location of lines with orifice runs is near. In considering the regulation, that is 2.5 meter levels, and control walls are usually located near the rack columns for convenient supports and keeping dimensions here, to keeping the dimension between the B and C or D or E to the lowest required level will minimize the length of pipes between the rack and process. And we have to consider that kind of process parameters in this elevation, so we can charge above or below the rack levels. Highest point here, can see the highest point and lowest point drain walls are provided to avoid the frustration during testings. This shall be pipe accessible to supports. So just That is the reason we have to wait here due to mobile data. So I can unable to connect and move the slides. Is it visible to everyone?
Yes,
Yes,
sir.
bro.
Okay, fine. Now see the piping arrangement. So in piping arrangement, here shown the different utility lines in the upper level and process lines in lower levels. And here mark some source that reserved for the uh, expansion lines. This is a typical cross section of two-tier pipe rack, and the help of P and diagrams means process and instrumentation diagram, equipment layout, piping specification, equipment drawings, and the vendor requirement for the preparatory equipments form the basis of a piping layouts. In area where piping is critical, the equipment location are fixed only after a piping study is made. This will facilitate the access to equipment after piping is in place, and also to have the most economical piping routine. So that kind of routines can see through this typical cross section of pipe rack. For petrochemical plants, piping shall be arranged in an orderly manners and routed as differently as practical established in piping engineering. So you will see the single tire pipe racks. So piping should run at different elevation. The basic principle to be followed in such cases is change in direction. See here, you can see the change in direction. uh, in change in direction, change in elevation, combined change in direction and change in elevation is affected by 90 degrees. So here we have placed the 90 degrees elbows, and to consider the change in direction, change in elevation, and combined change in direction and elevation is affected by 90 degrees elbows. We are already discussed different kind of elbows, 45-degree elbows. Now here we install 90 degrees elbows to required minimum change in elevation as per the requirement of piping industries. So we can combine the that is 90 degree and 45-degree elbows may be used. So here there is a combination of 90-degree and 45-degree elbows may be used with the by considering the final layout in piping engineering installation. Although the final stress analysis, whenever we are considered, the stress analysis will be done after routing the finalization. Primary check for monogram is required to establish the requirement and size of expansion loops, and some pipes are going down and some pipes are going up. In that direction we have to consider the stress analysis, and we can consider the flexibility temperature can be obtained from the line list. The lines requiring expansion loops is placed on the top level of the pipe rack. The line that requires the largest expansion loop must leg may be located on the outside. The loop shall be arranged with the portion of the loop getting elevated the rack level by two 90 degrees bends. So bends manufactured by vendor standards, that is we call the MSSSP, that kind of uh, fitting components manufactured by these standards. So this will allow the straight run other than lines on the rack and also provide additional flexibility. The proper dripping leg and steam traps shall be provided for steam lines to avoid the condensate collection in these points. So here we can see the no difference in elevation, and another is a group of lines with expansion loops, that is the hottest and largest line outside. So here you can see the elevation difference, that is 800 to 1200 millimeters, so we can change in the direction. So in different expansion loops is provided for hot lines to consider the changing direction, that is every 30-meter distance when we have to consider the directions. So here we can consider the drip and steam traps. So that is a typical arrangement of hose station along the rack, and the overall pipe rack design must be meet the current needs as well as the expansion plans. Without major modification, heavy large diameter piping may be laid below the ground on sleepers as established by economics. And we are discussed about the wall location. So here we have to consider the wall location. That is, accessibility to walls and instruments should be the primary concerns, while arrangement the same on the piping. The process isolation wall should be readily accessible, and elevation of 1200 to 1500 millimeter from the grounds that we call the operating levels. If at elevated levels, they can have chain operators. So here we can see the chain operators can mark from the 600 elevation, 800 elevation, 1100, 1300, and prox here we have to consider the 1700 elevation. So walls located at low or high location can have extended stems to reach the access cells. One thing must be ensure that stem will not be oriented below horizontal lines. This is very important. If you extend, then utility lines have pumps will be affected. Therefore, we have to consider the utility lines have two groups of walls. One group is closely related to process and should be located having accessibility just like process walls. The other groups contain all isolating walls such as block walls on headers, root walls on subheaders, and walls for future connection. These walls are seldomly used and are located on the overheads. Temporary ladder accessibility in is acceptable for such walls. Here, battery limit isolation walls can be provided with access platforms, and the walls are staggered on either side of the catwalk. See, here the walls are staggered on the either sides of the catwalk. When a pipe rack enters a unit, the elevation changes may be required. The block wall would be installed on vertical leg. In this case, this allows relatively easy operations. Shows two level racks with considering the elevation changes above or below the utility process equipments and to avoid the accessible spots. So that kind of arrangement is essential in this pipe rack arrangements. Now next is electrical and instrument tray. Why we are using electrical and instrument trays in piping engineering or in process industries or petrochemical industry? The electrical and instrument cables, that is we call instrument cable tray or duct location, is coordinated in the design planning phase itself and integrated in the overall arrangements. The space for these trays are provided above the piping rack. So here you can see the piping rack. So here we can provide the electrical and instrumentation trays that we have to specify the locations, whatever allotted location, including the type of supports. Later we will discuss the what kind of supports we are using in the rack, so that electric and instruments hardwares and their support do not interfere with the operation and maintenance access. So next is piping for instrumentation. Piping for instrumentation So instruments when located on piping will need certain specific requirement for it to perform the duty for which it is provided. Piping engineers should be aware of these requirements and should take care of the same while routing these pipelines. In first case, flow measurement instruments need certain straight length upstream and downstreams of the instruments. This is normally 1.5 diameter on the upstream and zero point 0.5 diameter on the downstreams. And in second case, the pipelines in which flow meters such as magnetic flow meters, vortex meters, turbine meters are located should be routed in such a way that the line will be full with liquid at all the times. The pipeline should be supported on both sides of meters. Now, in third case, control valves are located at grade at about 500 millimeters height to provide convenient access for operation and maintenance. And block and bypass valves are also form the same criteria. The standard arrangement followed as per the given pipe rack design, if pocketing the process line is unacceptable. So that kind of arrangements are not considered. On the edge of the yard with orifice flanges near rack columns for access. With the portable ladders, orifice run after pumps can be located near supporting columns at 2.5-meter level. So that much height to consider in the plant, and various structural elevations are determined considering the regulatory guidelines for the requirement of headrooms, the given their appropriate size of the supporting beams should also be taken into account while finalizing the structural levels. Generally, the lines that connect two lines located at a level higher than the top tire should run on the top tire of the rack. Lines having one end located elevation lower than the bottom tire can run in the top or bottom tires. If both ends of a lines are lower than the bottom tire, the line should run on the bottom tire of the rack. The elevation of lines can be influenced by the wall and instrument locations in for piping instruments. And access platforms are required to provided if walls are to be placed on the top at the rack levels. This is the required arrangement for instruments and equipments in piping engineering. Now, next is statutory requirements. The layout designer should finalize himself with law of the land while planning the equipment and piping arrangements. The requirement as per the different criterias. We'll see, first one is a Factory Act 1948 and Petroleum Act 1934 and the Petroleum Rules 1976. The static and mobile pressure vessels, that is we call the unfire, we cannot consider the fire, so comes under the rule 1981. Now next is gas cylinder rules as per 1981. Then Indian Boiler Regulation Act 1951 and Development Control Rules by the State Industrial Development Corporations. Yeah, same slide. Electrical and instrument tray piping. Just I have not finished statutory requirements. Right now I finish considering different acts. So here, I'm same slide, same slide. We are discussing third point, statutory. I have not entire each and every lines below statutory requirements. If you add a number of points, then slide will be increased. So I write only key points. Based on that key points, we will discuss. There is no need to add each and everything. And next one is miscellaneous. What kind of miscellaneous is required? So as far as concerned, the miscellaneous and critical examination techniques. First, we'll see the critical examination techniques. The quality of the equipment and piping layout can be established by the critical examination techniques, where you ensure that all the parameters are well addressed in the piping layout in process industry as well as in petrochemical industry. Now, first, it is a process adequate. First point we have to consider in critical examination. Next one is it is a operator friendly, or it is construction clears, has the adequate maintenance access provided in the piping layout and instrumentation, how to evacuate in case of emergency, and standard practices where applicable has been adopted, and is the piping arrangement aesthetics, supporting arrangement adequate and aesthetic, is piping adequate flexibles. Then see the different kind of critical examinations. Based on that we can perform the critical analysis. Is it clear? So these are the points. Based on that we can analyze the piping layout and instruments in process industry as well as petrochemical industry or refinery industries. So now, if you have any questions, any doubts, online as well as offline, so you can ask your doubts.
So can you send the
Yes.
attendance?
Yes.
Can you send the attendance?
Okay. Amar, Aditya, Athar, Aditya Singh,
Yes, doubt, sir.
are you there? Do you have any questions, any doubts? Yes, anyone? Amar?
Yes, sir.
Yes. Do you have any question?
No, no, sir.
Okay, fine. Then we'll close this session here and we'll continue tomorrow at 9 o'clock.
Okay, sir.
Okay, fine. Just wait. I will share attendance.